Assalamu alaikum everyone. My name is Zaliha and the topic that I'm going to present today is shape memory alloys part 2. In this video, we will cover the topics like applications of shape memory alloys, their advantages, limitations and future directions. So let's start with the biological applications of shape memory alloys. Shape memory alloys, especially nitinol, have made a major impact in the field of medicine. One of its most important application is in stents. Particularly self-expanding stents are made up of nitinol. These are inserted into blocked arteries in a collapsed form and expand with the help of body temperature, restoring the blood flow. They are also commonly used in cardiovascular, neurovascular, and peripheral vascular surgeries. The second application is in orthodontics. In orthodontics, nitinol wires are used in dental braces to apply constant and gentle force to teeth, gradually moving them into desired position. These wires take advantage of the body's natural heat to recover their original shape, offering both comfort and effectiveness. The next application is in guide wires and catheters. Nitinol is also widely used in guide wires and catheters, especially for minimally invasive surgeries. These tools are highly flexible and resistant to kinking and return to their original shape after being bending, which makes them ideal for navigating blood vessels. The next application is bone anchors and staples. In orthopedic surgeries, nitinol-based bone anchors and staples are used to align bones properly. Their shape memory allows them to return to a tight fit once activated by the body temperature. Additionally, the next application of shape memory alloys are surgical tools. Surgical instruments such as graspers, clamps, and snares made from nitinol are used in delicate procedures because they combine flexibility and durability. These tools can automatically move or tighten when exposed to a temperature change. These are commonly used in surgeries. The next application of shape memory alloys is in implants and filters. Vena filters made from nitinol are inserted into the veins to catch blood clots before they can reach the lungs. Thanks to shape memory alloys, these filters can be delivered in a compact form and expand automatically once they reach inside the body. The next application of shape memory alloys is in optometry. In optometry, shape memory alloys are also used to create flexible eyeglass frames, as you can see in the diagram. Brands like Flexon and Titan Flex use shape memory alloys material with transition temperatures set below the room temperature. This allows the frames to bend significantly under stress but return to their original shape when released. These frames are most commonly used in everyday life. Applications in aerospace. In aerospace, shape memory alloys are transforming design and efficiency. One of the most major application is in morphing wings, which can change the shape mid-flight to reduce drag and improve lift. It means that by changing the shape of wings during the flight, the experience of flight can be enhanced with, with the help of reducing the friction. The next application is vibration dampers. SMAs are also used in vibration dampers, helping to reduce the noise and maintain stability during the flight. It helps to reduce the turbulence that are experienced normally during the flights. Furthermore, thermal actuators. Thermal actuators made from shape memory alloys are employed in high temperature areas to control valves and flaps. Moreover, Shape memory alloys are also used in satellites for self-deploying components like antenna and solar panels that expand using heat after launching, eliminating the need for motors or hydraulics. Applications of shape memory alloys in automobiles. In automotive industry, shape memory alloys are replacing the traditional components in many ways. For example, they serve as actuator to move the parts like mirrors, vents, and headlights more efficiently and silently than electric motors. It helps to save time and reduce noise pollution. Thermostatic valve made from shape memory alloys automatically regulate engine cooling by reacting to temperature changes. Shape memory alloys also support adaptive aerodynamics by adjusting the grills or spoilers to reduce the drag and friction. In crash safety, shape memory alloys can absorb the impact and return to the original shape, thus minimizing the damage caused during the accident. Additionally, they are also used in electrical vehicles for battery cooling systems and charging port covers and smart locks for keyless entries. A few other applications of shape memory alloys. The first one is robotics. Shape memory alloys are being increasingly used in robotics, such as in prosthetic hands. These prosthetic hands are being developed by a company known as Bionic, which can mimic the size of human hands. The next application is in civil structures. In civil engineering, shape memory alloys are embedded in intelligent reinforced concrete to actively reduce vibrations in bridges and buildings. They also help to tune the natural frequency of the structures. The first consumer application of shape memory alloys is in piping, where the shape memory coupling were used to connect the oils or water pipe. The coupling is expanded to fit over the pipe, and once reheated, it shrinks tightly for a secure connection, an example of the practical and reliable SMA use. As you can also see in the diagram, the first two pipes are being deformed or and then they move over to each other and fit on each other. Once they are heated back, they squeeze for tight fit. Advantages of shape memory alloys. Shape memory alloys offer several advantages over traditional materials, like they have a very high power to weight ratio. It means that they are lesser in weight but are very powerful, allowing the strong movements with minimal mass. They require only accessible voltage to activate transformation. Shape memory alloys also exhibit high strain recovery, excellent corrosion resistance, and silent operations, making them suitable for sensitive environment. The property of corrosion resistance is very helpful in preventing the shape memory alloys from environmental attacks. Their compact size enables miniaturizations in actuators and devices. Limitations of shape memory alloys. Despite being having lots of benefits, shape memory alloys still have some limitations. First of all, they need efficient heat dissipation mechanisms, especially during repeated cycling. Shape memory alloys are less stiff and more flexible than metals like steels, which can limit their use in structural applications. They are also relatively expensive to produce and machines and tend to have a lower fatigue life. It means that they cannot bear a lot of load, meaning they can fail after few cycles compared to the steel components. Future scope of shape memory alloys. The future of shape memory alloys is very promising. Researchers envision them being used in cars and aircraft engines, as well as in electrical generators that can convert shape change into energy. Nitinol could also be used in automotive frames due to its shape memory properties. Other expected uses include shape memory alloys, springs for engine cooling, and fuel saving technologies like radiator blinds that reduces the airflow during engine startup to lower fuel consumption and exhaust emission, which is helpful in lowering the pollution. If we summarize all the topics, we can say that shape memory alloys are paving the way for innovation in medicine, aerospace, automotive, and structural engineering. Ongoing researches in material sciences and robotics continues to expand the possibilities of shape memory alloy technology. With more products entering the market and new ideas being tested, shape memory alloys have a bright future across many fields. Thank you so much. That was all from my side.